welcome to the video on Newton's method. So an overview of Newton's method is basically that it's a method used to find zeros of a function, or where the function value, or the y value of a function is 0, so where our x-intercepts are. So graphically, this is what it could look like. So let's say we have our x and y axes, and then if we have a graph like this, okay? So this is our f of x, that's our graph, and we want to find this 0 right here, okay? That's what we want to find. But what we usually do in Newton's method is we start off with what's called an initial guess, called x naught. So our initial guess here is called x naught. Okay, so that's where we guess that the 0 is, which, as you can see from the picture, we're kind of way off. But don't worry, we'll get there soon enough. So from Newton's method, what we're going to do once we have this x naught is find the value of the function at that point. So here, this point, this is at a height of f of x naught, okay? So the point itself is x naught, comma, f of x naught, okay? So we're at this point, and then at this point, what we're going to do is draw a tangent line, okay? So we're going to draw a tangent line at that point that I just drew. Okay, so if we draw a tangent line there, we're going to get something that looks like this, okay? So here's a tangent line, right? And the equation of that tangent line is going to be that y is equal to our f of x naught, so the height at which it crosses, okay? And then, which it touches the graph, and then plus f prime of x naught, and then times x minus x naught, okay? So this is the equation of our tangent line, all right? That's the equation there. And now what we're going to do is find the x-intercept of it. So here's our tangent line. This is the x-intercept, right? And now we're going to make that x-intercept our new x sub 1, okay? So to find that x-intercept, that means that at that value, at that point there, then our y is equal to 0, right? So we want to make our y equal to 0. So then we have 0 is equal to f of x naught plus f prime of x naught times x minus x naught. Okay, so if we actually go through and we're trying to find at what x value is our x sub 1, so this here, this is the unknown, this will end up being our x sub 1, okay? So if we solve for x sub 1, we would subtract that f of x naught minus f of x naught to the other side, so then we get that this negative f of x naught is equal to this thing on the right side, because these go away. Right, so then eventually we're going to get to the following fact. So I'll write that on the next slide. So at this point we're at negative f of x sub x naught is equal to a positive f prime of x naught times x minus x naught. Okay, so then we're going to divide by that f prime of x naught, f prime of x naught. So then we get that we have x minus x naught is equal to a negative f of x naught over f prime of x naught, and finally the last step here, we're going to add that x naught over. So then we get that x, or the x value that we want, so that's x sub 1, is equal to x naught minus x naught minus our f of x naught over f prime of x naught. So again here, this is, I'll draw it on the next slide, okay? So we're going to draw our graph again real quick. So we have our x and our y. Let's say here's our graph, right? So here was our initial guess, x naught. And now, after drawing that up to the graph, and we draw our tangent line, right? So here's our tangent line there. And this is what we just found, our x-intercept. That is x sub 1. So x sub 1, again, that is x naught minus f of x naught over f prime of x naught. Okay, so after this point, we are a little bit closer, right, than x naught was to the real root. This is what we want. So we're getting a little bit closer, so what we're going to do now is just repeat the process, okay? So we're going to draw that line up, find the value of the function, draw our tangent line there, tangent line, at this value here, and then what we're going to get is that this x sub 2, which is even closer, as you'll see, to our real root, x sub 2 is going to look like x sub 1 minus f of x sub 1, and then over f prime of x sub 1, okay? So here and then we can even keep going and keep going. But the pattern, the overall pattern that we see is actually something like x sub n plus 1 is going to be equal to x sub n minus f of x sub n over f prime of that x sub n. Okay, so that's the pattern that we see going on here. Alright, so basically, like we've started here, we're going to just repeat this process over and over again, as much as you would like, or just as much as the question asks you to, right? If they ask for x sub 2, then that's what you'll go up to, and then you'll stop, right? But anyways, so as far as accuracy goes, though, it's been agreed upon, I guess, by mathematicians, that if our x sub n and if our x sub n plus 1 agree to a certain decimal place, so we'll say agree to however many m decimal places, okay, then it's safe to assume that our real value, or our real root, to assume that this, so x sub n, that, I'm trying to finish a t there, so that x sub n agrees to a root, so the real answer, right, the real x value, to m decimal places as well, m decimal places. Okay, so that's how accurate it is. That's just a measure there, a quick measure. And that's pretty much it. So here on the next slide, I'll address Newton's method. I'll state it formally. So Newton's method basically just says it is. So Newton's method is used to approximate. So to approximate a root, so a value, a solution, of f of x, our function, is equal to 0. So what we do is we choose an x naught, which is our initial guess, right? So our initial guess, sometimes the problem will give you the initial guess to start with, which is pretty nifty. And then we're going to generate the following terms, or they call them successive approximations. So everything coming after that initial guess, right? So successive approximations called x1, x sub 1, x sub 2, x sub 3, and so on and so forth, where, and I'm going to write our pattern formula, right? So x sub n plus 1 is equal to x sub n minus f of x sub n over f prime of that x sub n. Okay, so that's our all-important formula for Newton's method. Alright, so now let's get started. Let's do an example of this. So what we're going to do is use Newton's method. Okay, so we're going to use his method to approximate, well, we're going to approximate something, but it's also going to give us an initial guess and an initial guess of x naught is equal to 2. To calculate, let's see here, to calculate our x sub 1 and x sub 2 for the following function, for our f of x is equal to x to the third minus a 10. Okay? So this is what we're going to do in our formula for x sub 1, for example. So we already are given our x sub 0. So x sub 1 is equal to this x sub 0 minus f of x sub 0, or not, x naught, f prime x naught. Okay, so we have everything. We have this is equal to 2. We could plug in a 2 here in for our function, which we do have, but we don't have f prime of x. So let's find that. F prime of x is simply going to equal a 3x squared. Okay, so x sub 1 is going to equal 2, if we plug that in for x naught, minus f of 2 over f prime at 2. Okay, so let's find f of 2 and f prime of 2. So we have f of 2 is going to be equal to a 2 to the third power minus 10. So that's an 8 minus 10, so that would be a negative 2. And f prime of 2 is going to be 3 times, now our x is a 2 squared. So that's going to be 3 times 4, so that'll be a positive 12. Okay? So now, when we plug those into here, we get x sub 1 is equal to 2 minus a negative 2 over a 12. So these negatives cancel out, right? So we get plus. So 2 plus 2 over 12, which is a 2 plus 1 over 6. So that would turn out to be x sub 1 is equal to a 13 over 6, which is about equal to 2.1666. Okay, so keep this in mind. This is our x sub 1, and we're actually going to need it for our x sub 2. Okay? Alright, so now if we write the formula for x sub 2, we have, this is our n, this is like x sub n plus 1, so n is like a 1. Okay, so then we have x sub 1 minus f of x sub 1 over f prime of x sub 1. Okay, so again, our x sub 1 is equal to 13 over 6. We'll just use the fraction form, okay? So what we're going to do is have x sub 2 be equal to 13 over 6 minus f of this 13 over 6 over f prime of 13 over 6. So let's see when we plug those in. So we have f of 13 over 6 is going to equal that, so our fraction, raised to the third power, okay? And then subtracting 10. So that's going to be about equal to, this is about equal to 0.171296, okay? And then if we plug it into our f prime, 13 over 6, that's going to be 3 times 13 over 6 squared, which is about equal to 14.08333. Okay, so now we have those two values here, all right? So we're going to plug those guys in and see what we get. So x sub 2 is going to be equal to a 13 over 6, that is just in front, minus f of 13 over 6 is now 0.171296 over f prime of 13 over 6, and that's a 14.08333. And this is about equal to, so our x sub 2 is about equal to a 2.15450. Okay, so that's basically it. That's the second part of our answer. And the first part, again, that was 13 over 6, which is about equal to 2.1666. Alright, so that wraps it up for the video on Newton's method. I hope that helps, and good luck on your homework.